Saxon Algebra 1, Lesson 78. The name of our topic is rational equations. Doesn't that sound scary and hard? It sounds like that, but it's not. When we say rational, what we usually mean are fractions with letters. Well, we've been dealing with that fairly often. That isn't the end of the world. And when we say equations, that means we have equal signs. All right? So rational expressions sounds a lot more troublesome than they are. Okay? And we'll be doing a ton of rational equations and expressions. If we're doing rational expressions, that just means there's no equal signs. So we're going to practice these in a simple form, and then they'll get harder as we go. I'll explain as we go also. Solve. Okay. If you ignore the fact that those are y's, this looks pretty straightforward, doesn't it? We're adding together fractions that have these denominators. All right, what do we do in a problem like this? I'm going to write our steps over here. The first thing that we want to do, I'm kind of violent in my imagery. I want to blow up these denominators. I want to get rid of them altogether. And when we have an equal sign, we know that that's a realistic goal. If you have an equal sign, you can get rid of your denominators. Not just make them match, blow them up into little bitty pieces. We never see them again type of deal. I like to abbreviate this as denoms because it reminds me that sometimes denominators look a lot like demons. And so, who wants a demon in their math problem? Not me. So the way that we do this is first we find the least common multiple. Well, we've been doing that for 1,000,000 years, or at least 20 lessons. We know that what you do is you look at these numbers and you find the smallest number that all of these guys can multiply up into. In this case, I can see that it's 12. Cool. Now, what we do, and this is where it's different, we multiply every term by the LCM. Now, I have a very specific way I like to do that. I angle it up here. Right now, we're just writing a 12. That's pretty short. Later, we're going to write longer things up here, but I'm going to write it like this: times 12, times 12, times 12. Every term on both sides of the equal sign, every single term gets multiplied by 12. Now, what we do, so this shouldn't be step number 2. First we found the LCM, then we multiplied every term, and now we're going to cancel. This is all part of blowing up the denominators. Now, look what happens. When we multiply this first one by 12, 12 in the numerator, this is in the denominator, I can now cancel my denominator against this. And I'll be left with 6 that I need to multiply in my numerator. See how I did that? 12 divided by 2 equals 6. 12 divided by 4 equals 3. I will multiply 3 by what's in my denominator. And here, 12, 6, this gives me 2. I will multiply by what's in my denominator. All of these cancelings will come out even because we set this number up as our least common multiple. We know that each one of these denominators will divide perfectly into it because that's what an LCM does. All right? So now what we're ready to do is just rewrite what we have left. 6y plus 3 equals 2y. All right, I'm going to subtract 6y. And I get 3 equals minus 4y. And I'll divide by minus 4. And I'll get y equals minus 3 over 4. Final answer. Yay! Okay. So once we blow up the denominators, it's just algebra. Okay? But the good news is that when we have equal signs and denominators, we can blow them up. Okay? We don't just have to make them match and live with it, make them match and live with it. We can actually get rid of them. And that's why I really like rational equations. I like getting rid of my denominators. All right, 78.2. Solve. All right. There it is. It's an equation with letters and numbers. It's got fractions. It's got an equal sign. This makes me happy because it makes me remember that I can blow this up. Here's my explosion. Right? That's me blowing up my denominators. Okay, how do I do that? First, I find my LCM. 7, 2, and 3 are all prime numbers. That means they're not sharing any numbers in common, and the only thing we can do is multiply all this together to get an LCM of 42. All right. I'm going to use my colors again, but where'd my green marker go? Oh, man. Oh, here it is. Okay, so we're going to multiply every term by the LCM, guaranteed to allow us to cancel each of these into it. All right, 42 over 7, that cancels to 6. 42 over 2, ooh, that's 21. That's kind of a big number, but we can do it. Okay, how about 42 over 3? Let's see, that's 14, right? And I'm going to write times 14, I'm going to write it on this side. 3 times 14, I'm just double checking. 12 plus 1, yes, that works. Okay, so we've reduced that one as well. We carefully cancel the LCM against the denominator and write whatever's left here, and then we multiply it by what was there to begin with. So now we have 12x minus 62x, no, 63, equals 14. 12x minus 63, well, let's do this. 63 minus 12 would be 51. So this is going to be minus 51x equals 14. Divide both sides by minus 51. That seems really random, doesn't it? Let's see. I'm thinking that I'm wondering if this can be reduced. 14, I know, can break down into 2 times 7. Those are prime factors. 51 is prime. So there's nothing we can do to reduce because there's no way to cancel anything. So x equals minus 14 over 51. Remember that we can bring the minus sign out and float it. I'm okay with floaty minus signs. That's our final answer. And we have 4 of these in all. Next one's going to get a wee bit bigger. Solve. This is written as a floaty 3 in the book, but you know how I feel about that. I'm going to turn it into a fraction. All right. The first thing I see that makes me kind of nervous is we have a quantity here. We have 2 pieces in our numerator. So what I'm going to do is put it in a protective embrace. I like to put parentheses around my quantities. It just keeps them neat and tidy. It keeps them bundled together. And I don't know for sure what I'm going to be doing with this, but I just feel better knowing that it's pa-chunked together. Pa-chunked together? Yeah, that's a thing. Okay, our least common multiple is going to allow us to blow up this denominator. Prime, don't have to worry about it. Our least common multiple will be 14. So I'm going to multiply every term by the LCM. Now, 14 doesn't even have a denominator. It's okay. It'll be fine. 14 over 2 cancels to 7. I'll multiply 7 by that. 14 over 7 cancels to 2. Now, I'm very happy I have my quantity in parentheses because I'm going to have to distribute this. And the parentheses help me keep from messing up. 14 over 1 doesn't cancel, so this is just 14 times 3. Okay, so that's what happens if there's no denominator. It's fine, it just means you don't cancel anything against it. You just multiply the whole chunk right there. And now let's see what we've got. 21y plus, now let's distribute 16 minus 8y equals, what's this again? 42. All right, that's pretty good, right? Now we're ready to combine like terms. We can combine those and let's subtract the 16 at the same time. 21 minus 8 is 13y. That cancels. 42 minus 16, well, we can just do the subtraction right here, can't we? 26. John, you're so nice. And we get y equals 2, and that's the right answer. Okay, so we don't let quantities scare us. We just tuck them quickly into parentheses so that if we do have to distribute, which is normal, we'll be fine. That won't be confusing at all. If a number doesn't have a denominator, that's fine. You can put it over a 1, and then when you go to cancel, you'll realize, oh, that doesn't reduce, so I just multiply the whole chunk times the number there. Okay, and this is our last problem for lesson 78. And you'll see that John is testing us to make sure we know what the heck we're doing. Again, I have a quantity in my numerator. I have a plus, so I'm going to put parentheses around it right away. And look, this time he gave us double quantities. So that's fine. We'll just put them both into buckets, if you will. Protect them, right? All right, what we need is an LCM. All right, 4, 2, and 10. Well, for starters, they're all even. So I know that I don't have to just multiply them all together. What I can do is look at their prime factors. This is 2 times 2. This is just plain 2. And this is 2 times 5, right? So what I can do is I can make my LCM by listing these. I'm going to need 2 times 2 times 5. Now everyone can find themselves in that list, right? And then I can multiply. These are all prime, so I'm going to circle them. And then I multiply that out and I get 20. 20 is my LCM. All right? So that's a way to find the LCM if you're not if it doesn't just jump into your brain in an instant, list the prime factors of each of your denominators and then make a list so that everyone can find themselves in that list. That becomes your LCM. Green. We're going to multiply every term by the LCM. We're not worried about the quantities. We know that's going to work out fine. We just are double sure we want them now inside of the parentheses. 20 divided by 4 is 5. So I'll multiply that by 5, and I'm just going to draw this right now to remind myself. I'm going to need to distribute. 20 and 2 gives us 10. 10 times 3, that's an easy one. 20 over 10 is 2. And again, I'll have to distribute there. And I'm going to be super careful about that minus sign too. Make sure I see that. All right, let's do our distributions now. 5x plus 5 minus 30 equals 4x minus 18. That sure looks a lot better than that, doesn't it? I'm happy. Let's combine those. That will be 5x minus 25 equals 4x minus 18. We'll bring the 4x over to the left. Swim, little fishy, swim. And then we'll add 25 and get the plain number boys over here. That cancels. Ready? 5x minus 4x. Oh, I love when that comes out to just be x because then we don't have to, not extra step. Equals 18 plus 25 is 7. That's our final answer. Yay! Remember, here are the steps. Where are they? Oh, I see what happened. Look, I skipped a page when I turned. Here are our steps. To blow up the denominators, you find the LCM. You multiply every term by the LCM, then you cancel. And then once you get all that done, it's just algebra to solve. The other thing I just want to remind you of is when you have quantities, protect them right away. Get parentheses around all. Protect your quantities, which is to say numerators that have more than one piece. All right, 78. We'll be doing lots of work with rational equations. They are our friends. We will see them often. Goodbye.